A symphony of fury, the allure of thunderstorms, the sky darkens, a hush falls over the land, then it begins. The wind whispers, then howls. Raindrops pound the earth, a relentless drumbeat. Lightning, a sudden searing flash, illuminates the world in stark relief. This is the raw, untamed power of a thunderstorm. It is a spectacle that evokes both awe and fear, reminding us of the immense forces at play in the natural world. We are but observers to this grand performance, witnessing the interplay of air, water, and electricity. Thunderstorms, for all their destructive potential, are a testament to the dynamism of our planet. They are a reminder that Earth is not a static sphere, but a living, breathing system constantly in flux. Let's journey into the heart of these tempests and unravel the science behind their fury. Brewing tempests. The anatomy of a thunderstorm. Thunderstorms are one of nature's most awe-inspiring phenomena, captivating and terrifying in equal measure. Thunderstorms are like intricate puzzles, each one unique yet sharing common elements. They can vary greatly in size, intensity, and duration, but all thunderstorms follow a similar developmental process. They are characterized by towering clouds, heavy precipitation, and the ominous rumble of thunder. The visual and auditory spectacle of a thunderstorm is a testament to the immense power of nature. But what are the ingredients that go into brewing these atmospheric cocktails? Understanding the anatomy of a thunderstorm requires a closer look at the conditions that give rise to these powerful weather events. Warm, moist air is the fuel that drives these meteorological engines. This air, rich in moisture, is essential for the formation of the towering clouds that define thunderstorms. Imagine a hot summer day, the sun baking the earth. The intense heat from the sun warms the ground, creating the perfect conditions for a thunderstorm to develop. As the ground heats up, it warms the air directly above it. This process is crucial because it sets the stage for the next phase of thunderstorm development. This warm, buoyant air, laden with moisture, begins to rise, like a hot air balloon released from its tethers. The rising air creates updrafts, which are essential for the formation of thunderstorms. As this air ascends, it encounters cooler temperatures higher in the atmosphere. The cooling of the rising air is a critical step in the development of a thunderstorm. When warm, moist air cools, it condenses, releasing its moisture as water droplets or ice crystals. This release of moisture is what forms the clouds and precipitation associated with thunderstorms. This process of condensation forms the towering cumulonimbus clouds that are the hallmark of a thunderstorm. These clouds can grow rapidly, reaching impressive heights in a short amount of time. These clouds can reach incredible heights, sometimes extending over 10 miles into the atmosphere. The towering nature of cumulonimbus clouds is a clear indicator of the power and potential severity of the thunderstorm. Thunderstorms are most frequent in areas with warm, humid climates, such as the tropics. The abundance of warm, moist air in these regions provides the perfect conditions for thunderstorms to thrive. However, they can occur almost anywhere on Earth where certain atmospheric conditions exist. From the tropics to temperate regions, thunderstorms are a global phenomenon, showcasing the dynamic and ever-changing nature of our planet's atmosphere. Ascent and descent, the dance of updrafts and downdrafts. Within the churning heart of a thunderstorm, a delicate balance exists between two opposing forces, updrafts and downdrafts. These forces are constantly at play, shaping the storm's behavior and characteristics. These vertical movements of air are what give thunderstorms their structure and power. Without them, the storm would lack the dynamic energy that makes it so formidable. Updraft. Imagine a giant invisible chimney within the storm cloud, pulling warm, moist air upwards. This process is crucial for the development of the storm as it brings in the necessary ingredients for thunderstorm formation. This is the updraft, the engine that drives the storm's growth. The stronger the updraft, the more intense the storm can become, often leading to severe weather conditions. As the warm air rises and cools, condensation releases heat, further fueling the updraft. This release of latent heat is a key factor in maintaining the storm's energy and can lead to the development of towering cumulonimbus clouds. Downdraft. However, what goes up must come down. The downdraft is the counterpart to the updraft, and it plays an equally important role in the life cycle of a thunderstorm. As the rising air cools and condenses, it releases moisture in the form of rain or hail. This precipitation is often heavy and can lead to flash flooding in severe cases. This precipitation drags air downwards, creating a downdraft. The downdraft can be powerful, bringing strong winds and sometimes causing damage at the surface. The downdraft spreads out at the ground, creating the gust front, a rush of cool air that announces the storm's arrival. The gust front can be felt as a sudden, cool breeze before the main storm hits. The interplay between updrafts and downdrafts is a continuous dance, a delicate balance that determines the storm's intensity and longevity. This interaction is what makes thunderstorms so dynamic and unpredictable. When updrafts are strong, they can support the weight of large hailstones and produce torrential rainfall. These conditions can lead to severe weather warnings and require people to take shelter. Downdrafts, on the other hand, eventually cut off the supply of warm, moist air, leading to the storm's dissipation. As the downdraft dominates, the storm loses its energy and begins to weaken, eventually fading away. Understanding the dance of updrafts and downdrafts is crucial for meteorologists as they predict the development and potential severity of thunderstorms. This knowledge helps in issuing timely warnings and keeping communities safe. So the next time you see a thunderstorm brewing, remember the intricate dance of updrafts and downdrafts that powers it. This dance is a testament to the incredible forces of nature at work, constantly shaping our weather and environment. The spark of life, unraveling the mystery of lightning. Perhaps the most captivating and fearsome aspect of a thunderstorm is the lightning. These powerful electrical discharges are not only visually stunning but also incredibly dangerous. These sudden, blinding flashes of light, followed by the deafening roar of thunder, have captivated and terrified humans for millennia. The sheer power and unpredictability of lightning have inspired countless myths and legends throughout history. But what is the science behind these electrical discharges? How do these magnificent bolts of energy form, and what causes them to strike with such ferocity? Imagine the storm cloud as a giant battery, with different regions carrying different electrical charges. This complex system of charges is what ultimately leads to the creation of lightning. Within the cloud, collisions between ice crystals and hailstones generate static electricity. These tiny particles bump into each other, transferring electrons and creating an imbalance of charges. Typically, a separation of charges develops, with positive charges congregating at the top of the cloud and negative charges accumulating in the middle and lower portions of the cloud. This separation is crucial for the formation of lightning. The ground, influenced by the negatively charged cloud base, becomes positively charged. This interaction between the cloud and the ground sets the stage for a potential lightning strike. When the electrical potential difference between these areas becomes too great, it overwhelms the insulating capacity of the air. The air, which normally acts as an insulator, can no longer contain the immense electrical energy. The result is a sudden discharge of electricity. Lightning. This powerful release of energy can heat the surrounding air to temperatures 5 times hotter than the surface of the sun. This discharge can occur within the cloud, between clouds, or between the cloud and the ground. Each type of lightning has its own unique characteristics and behaviors, adding to the complexity and beauty of these natural phenomena.